Factoring binomials that are perfect cubes, that were in the form of a cubed plus b cubed, or it could be a cubed minus b cubed. So this is going to be different than the difference of perfect squares. So let's talk perfect cubes. On your variables, any power that is a multiple of 3, 3, 6, 9, 12, will be a perfect cube. If you have a cubed plus b cubed, or it could be a minus, it will not be 3 binomials in a row with the same sign. If I attempted to multiply that out and FOILed it, this is what I get. I get a bunch of middle terms here. So we never ever want to say that it's going to be 3 individual binomials. So in fact, this factors to 1 binomial and 1 trinomial. So if I was looking at this a cubed plus b cubed, I would want to write a binomial, 2 blanks, a trinomial, 3 blanks. Then what we're going to do is SOAP the signs. An acronym S stands for the same sign as you're given in the problem, so that's a plus. O is for the opposite sign that you're given. These two signs here are always opposite. AP is for the last sign, always plus. So step 1 and step 2 should now be done on the very first step. Step 3, you take the cube root of each of these terms to build this binomial. The cube root of a cubed, a. Cube root of b cubed, b. Once the binomial is done, I want you to smile. You're almost done. You're drawing a smiley face. A times a squared. A times b, ab. B times b, b squared. You can see the smiley face right there. All right, looking at some more examples, we're going to have numbers that you want to look at as the perfect cube. All right, so 27, that's 3 to the third power. 8 is 2 to the third power. This is perfect cube. So I need a binomial and a trinomial. Plus in the binomial, minus for the first sign in the trinomial. Step 1. And 2, if you will, also doing the signs. All right, take the cube root of each term. Cube root of 27 is 3. Cube root of y cubed, 3y. Cube root of 8 is 2. Cube root of x cubed, 2x. Smile, almost done. 3y times itself, 3y. 3 times 3 is 9. Y times y is 9y squared. 3y times 2x, that's going to be 6xy. 2x times itself, 2x, 4x squared. 64x cubed minus 125. 64, that's a perfect cube, 4 to the third power. 125 is a perfect cube, 5 to the third power. So binomial with the minus sign, trinomial with 2 plus signs. Remember, these two are always opposite of each other. Cube root of 4x cubed is 4x. Cube root of 125 is 5. Time to smile. 4x times 4x is 16x squared. 4x times 5 is 20x. 5 times 5 is 25. We are done. Now, it's important to understand that this trinomial right here does not factor. So this will not factor to 2 binomials, so don't even bother trying. X to the 6, y to the cube with a minus sign. So minus on the binomial, plus on the trinomial. Take the cube root. So again, cube root of x to the 6, divide the power 6 by the root 3 is a 2. Cube root of y cubed is just y. Cube root of 216 is 6. Time to smile. X squared times x squared, y times y, x to the 4th y squared. X squared y times 6, 6x squared y. 6 times 6, 36. 1000 is a perfect cube. That's 10 to the third power. 343 is 7 to the third power. So binomial with a plus, trinomial minus plus. Take the cube root of the first term is 10x. Cube root of 343 is 7. Time to smile. 10x times 10x, 100x squared. 10x times 7, 70x. 7 times 7, 49. All right, here, factored completely, we have an A and a 2 that need to come out as the GCF. And now we have perfect cubes. Minus in the binomial, so minus, then plus. Always plus at the end. Looking at just the inside, the 2a is part of my answer. Cube root of 8x cubed is 2x. Cube root of t cubed is t. 2x times 2x, 4x squared. 2x times t can be 2xt or 2tx. T times t squared, we're factored, we're done. Now, on this one here, 64x to the 6th minus 1, we got to be very careful, because this is both the difference of perfect squares and its perfect cubes. 64 is a perfect square. Square root of 64 is 8. But it's also perfect cubed, as we saw up here. Cube root of 64 is 4. X to the 6th, that's an even power. That's a perfect square. 6 is a multiple of 3. It's a perfect cube. 1 is both perfect square, perfect cube. So when we run into something like this, anytime you see an x to the 6th with a 64 and a 1, you always do the difference of perfect squares first, perfect cube second, because this trinomial doesn't factor. So we don't want to get stuck trying to figure out how do we factor this to two trinomials when it's not going to. All right, so difference of perfect squares. Square root of 64 is 8. Square root of x to the 6 is x cubed. Square root of 1 is 1. 1 plus 1 minus. Now this becomes two perfect cubes. So I'm going to get a binomial, trinomial, binomial, trinomial. Plus, minus, minus, plus. Now, we've already looked at the 8x cubed over here. So as we figure this out, we take the cube root of this x cubed. That's going to be 2x, so you might as well put 2x over here as well in this binomial, because this 8x cubed is going to give me the same 2x. Cube root of 1, that's a 1. Cube root of this one, that's a 1. So as you build the first binomial, build the second one at the same time. And that's going to be true for the trinomials here. It's time to smile. 2x times 2x, that's a 4x squared. Well, this will be 4x squared because we're going to take this 2x and multiply by itself. 2x times 1 is 2x. Put it in for both middle terms. 1 times 1 is 1. Put it at the end of both trinomials. And now we're factored. And that's our perfect cubes.